mainly. It actually has a real focus on things that are associated with functional programming and so on. I personally wouldn't go so far as calling it a functional programming language, but it has those aspects, and as a Perl person, where we also have those functional aspects, I can be very happy with JavaScript because I can use it in those ways. It's also important to know that Chromebook for All is sort of complaining and talk about discipline and so on, also introduce positive ideas in this. It's quite evident when you go and read the book, actually, with the good parts. For example, functions are very, very central and powerful. If there's one thing that JavaScript got so very right, it's the function abstraction. In fact, you could argue somewhat meanly that it's the only abstraction that JavaScript has, really. It doesn't, in early versions, it doesn't have classes or interfaces or modules or anything, but it does have functions. So what you end up doing, if you want to sort of reach the higher levels of abstraction and actually use those ideas, is to emulate all those things using functions. Not because that's nice code, or not because that's highly clever, but because you can, and it's the only tool by which you can do that. For example, one idea that Crockford champions is using closures to create a private space for an object. Ordinary objects in JavaScript are entirely public. Every method and every property in an object is reachable from the outside by anyone who cares to look at it. But if you return that object from inside of a function, and you have methods in your object that reference things in the function, then those things will be private. So you can sort of emulate privacy here in a very clever way by using the closure mechanism that is already in JavaScript. So you do var foo or let foo in your function, and then you return the object, and the object has methods, and the methods sort of contain a reference to foo or use foo in some way. That variable foo cannot be reached from the outside. It was sort of created by the function. The function acts like a kind of object factory in the sense. Every time you call that function, you get a completely new object with its completely separate link to its completely separate variable foo. So it ends up being the moral equivalent of a private variable. That's a really, really cool trick to use, and I encourage everyone to sort of get to know that trick because it's very powerful even in other languages that are not JavaScript. Crockford is also responsible for JSON. Now, JSON is simply the idea that JavaScript has something going on there with its simple values, numbers, strings, booleans, the null value, and then arrays and objects. You combine all these and you allow a person to do anything they want with these. Then you have a pretty good data format, actually. It sure beats the heck out of XML, which often ends up being quite as long and frustrating to read and write, and JSON just comes in as a fresh breath of air with the minimal amount of syntax to get the job done. So JSON is sort of kind of a subset of JavaScript. It's JavaScript written in a particular way, and you just keep the value. You have no variables and no statements or anything like that. And then you put the value in a file, or you transmit it across the network and so on, and that turns out to work really, really well. So I would say at this point, even though XML is far from dead, JSON has taken a big share of that mind share, definitely. And that's also Crockford's doing. He basically came up with JSON as part of some project and then published it on a web page, and now it's a thing. Now everyone's using it. During this decade, the 00, so the noughties, we also get some version development with JavaScript versions or ECMAScript versions. We sort of in the beginning landed on ES3. Everyone was using ES3 or slightly older, and that became the tool for many, many years, basically that entire decade. And then ES4 is kind of, we don't talk about ES4, because it was the first attempt for that committee to get some traction and get some evolution of the language. They tried too hard. They wanted to fit everything in. It became sort of a big, huge beast that tried to be everything for everybody. And the slogan, "Don't break the web," came up again, and then it became a real problem. You couldn't get anywhere in those committee meetings. So it was scrapped, basically. It was referred to as Harmony ES4. And at some point, people just started over and said, this is not working, let's call it ES3.1 and be much less ambitious. And ES3.1 eventually evolved into ES5 instead. So ES4 was a dead end with sort of a lot of attractive ideas that eventually were resurrected in later versions. But that didn't take hold at that point. When we see the timeline as we do from today, we kind of see that ES4 was a missed boat. We could have done some nice things earlier, but we would probably have also done some horrible committee decided glitches along the way too. So it's both good and bad that didn't lead anywhere. Nowadays, since about the turn of the decade, ES5 is the sort of new gold standard, and we can basically assume ES5 everywhere with very, very few exceptions. If we cannot assume ES5, we can at least assume ES3. And ES6, as you see, at this point, we are starting a yearly cadence here, so a new version of JavaScript is expected every year, a new version of ECMAScript. And so we have year numbers as well, besides the versions, and people are actually encouraged to use the year numbers. I still cannot make myself really do it. I think about it as ES6 as well. It also frustrates me that if they had just waited a year to do that, then the one-digit number would sort of correspond, but they just couldn't wait, I guess. Maybe someday we'll sort of catch up and come to think. I want to talk a little bit about his features later. But now ES5 is industry standard, and it's also, as nice as it is, we're now also getting used to those features, and they are starting to feel a little bit old, and that language is becoming a little bit limited. But at least we can assume that it's in virtually all the browsers, which helps a lot. Actually, speaking of browsers, one problem that we had for many, many years was that we were basically waiting for the market to kill off various browsers. Here you see it's an old screenshot, people waiting for Internet Explorer 6 to die. Why do you wait for a browser to die? Well, again, because your visitors are using this horrible browser, and the browser can do next to nothing, or it does it in disgusting ways, or it leaks memory all over the place, or it crashes all the time when you use a certain feature and so on. So, and you try to fix this, and you try to do a workaround, and sometimes that works, sometimes it doesn't, and you just have to stay off using a nice feature that you want because of this browser, or rather. And Internet Explorer 6 for a long while was the bane of many web developers for this reason. They had a number of bad, unfixable things that just didn't go away. My favorite there was some company, I forget which one, but they actually did this. They were retailers, you could buy things online, and when you got to the checkout counter, they added for Internet Explorer 6 tax, and you got 10% extra that you had to pay because you were using this whole browser. I love that. That's exactly the right approach to get people to sort of vote with their wallet and then actually upgrade their browser. And then we waited for Internet Explorer 8 to die for much the same reasons, and there was a page for that as well. You don't hear things like this much anymore, and it's because of evergreen browsers. And I really like this. It's as far as I know, Chrome started with this. It's the idea that your browser is actually, of all the applications on your desktop, the browser is sort of guaranteed to be online because that's what you're using it for. So why shouldn't it just, like Ajax in the background, just go and get something? It just updates itself. The next time you start it, you're starting the new version. That's great. That's such a big progress. The easiest way to get people to have fresh browsers is to do the work for them so that they don't have to go and install something new. I mean, obviously, and similar dynamics are not exactly the same when you have a mobile device and you actually sometimes update your apps and so on. So nowadays we're in a much, much better situation where new JavaScript features and other new web features can actually roll out on a schedule of months instead of years or decades. The next person we're going to mention is right across the Øresund waters here, Lars Bak, not the Danish cyclist, but the Danish compiler developer. Lars Bak came up with a new engine in connection with the Chrome browser, which is called V8. So now we're up to September 2008 here. V8 was revolutionary in that it did things to JavaScript that no one had thought about doing earlier. And this is one of those mental blockers again. JavaScript is a scripting language, right? It's an interpretive language, so what can you do? Everything is so dynamic that you basically cannot optimize it. But V8 could. And this was a total game changer. We're talking about the kind of compilation of the language which makes it, so to speak, close to the metal. I mean, some of the time when you're running V8, you're actually interpreting instructions and everything is nice and slow as in the old days. But sometimes the just-in-time compiler takes in and says, hey, I see you've run this function here like 150 times. How about I go in and take what I know about the dynamic runtime process and think of those patterns that I see as actual constraints. I see, like, out of those 150 times, you've popped a string in here exactly 150 times. I'm just going to make that a rule. Now it's a string. My compiled code is a string. And I compile this down to machine code. The machine code is really nice and fast. It runs directly on the machine. And it has some nice, some simple check as well, because you have to, at any point it's not a string being passed in, you sort of get a penalty on it, uncompile it, and go back to interpreting it again. But probably not, Probably you've been a good programmer and you always pass in a string there and you always get the fast version. Reasoning like that made V8 a completely different JavaScript runtime engine than anything before. And it just blew every other engine out of the water, and suddenly everyone except Google said, oh shit, we need to do this also. We need to make our JavaScript engines so that we are not, 100 or 1,000 times slower than JavaScript on Chrome. So that was important. Another thing that, just talking about these nice optimizations that V8 does, is changes the shapes of your objects, which is, everything is so dynamic in JavaScript. You can add and remove properties and sort of change their type and so on as you go along. But usually in a fairly thin JavaScript program, you will have an object that looks the same from the start, and you just update some properties along the way. But the shape stays the same, and it's predictable, and you can use it as part of your analysis in making the program. It's called, I think, pseudo-classes or something like that. So it's not real classes in the JavaScript language at this point, but V8 creates a pseudo-class when it sees what you're doing with the object. And then, again, there are various kinds of things that it can do to slow things down again. For example, if you use the delete keyword that we saw for arrays, if you use that on an object and delete the property, all the nice optimizations go away all of a sudden because you change the shape of the object and all that sort of. So this was really, really important. And so by extension, the whole image of JavaScript now needed to change. If it can be fast, then it can also be a serious language, and it can also be used in the enterprise. Maybe we can do something with this. Maybe we have to do something with this. And so the next person steps on the scene, Ryan Dahl, and his idea is simply to take JavaScript out of the browser, to say, we can just run JavaScript, for example, on the server or in your local development environment, or on a small embedded device, or whatever you want. Because this V8 thing, sure, it's sitting in Chrome, but it really doesn't have to. So JavaScript runtime is very fast. We run it wherever we want. And that was a big thing in itself. This wasn't Reinfeld's only idea, though, and it's really good that it wasn't, because asynchronous programming turned out to be a big topic for this decade. Just to remind everyone, when you have synchronous programming, you make a function call and everything stops. So execute goes into that function, and you come back out and you continue with the rest of the program. But the rest of the program has had to stop and wait for that function to finish. This is all fine and good and well in a non-network environment. But in a networked environment, just like when you call for a pizza, you don't expect to stay on the line until they finish your pizza and deliver it. You cannot afford that kind of locking. That also goes on the network. The node which makes an AJAX call, for example, expects to be able to do things while the request goes out, processing happens on the other end, and the response comes back. You don't even know if you will get a proper response. Maybe you will get an error. And so you install handlers for these things and do things that way. And Node.js, unlike JavaScript, was designed with this in mind from the start. So if you want to request a file from the file system, the default function to do this was asynchronous. So you started programming in an asynchronous style. And actually, Ryan Zoll made a little bit of a bet on this. The way you do it in default Node.js is to pass the handler. What happens when this result comes back? You pass that as a nested function, as an argument to your the content of this file function or whatever. You end up passing a lot of functions into functions, and your program ends up being very, very nested. And it's, to be honest, not very pleasant to look at. People started talking about the pyramid of doom because your code got more and more indented, and then it got less and less indented, and people started swearing about missing a closing brace or a comma somewhere or a semicolon, and you at least needed a really good editor to keep track of everything for you and not go crazy along the way. The pyramid of doom is a little bit of a red herring. The actual problem with nesting functions in functions like that is that we lose the normal nice conveniences of the ordinary JavaScript language, such as try-catch statements or breaking out of a loop or something like that. Because your primary idiom now is just passing functions into functions all the time, you shadow yourself from the rest of the language, and you make the language a little bit weaker and more narrow by doing that. Nowadays, we know a much more pleasant way to do this. It's called promises, and it's a sort of standard or an API that has a specification that has evolved across the years, but that wasn't available back when Node started. So this was probably a good bet actually to do, that Ryan did. And nowadays, if we want to use the new fancy promises style, and we probably do want that, it's super trivial to just take all the existing continuation passing style functions and just also convert them to promise using. So that's what people do nowadays. So it was a good bet, actually, not to settle on some, half-useless proto version of promises that wouldn't be valid today, but to do it sort of built into the language even though it wasn't perfect. Node.js also brought in a lot of other nice things. Since we were now using JavaScript in our development environments, we could start thinking in terms of build toolchains. It's everything like, maybe we want to tweak our program a little bit along the way before we show it in the browser. Maybe we want to bundle 10 or 20 or 100 JavaScript files into one single file and just import that one from the HTML. It's also things like linting. Linting in the past year has been the eye-opener for me. I used to have sort of a healthy skepticism for linting and say, sure, it's good, but I already write pretty good code, so I don't need that. But it turns out that if you have a linter, it actually does find a lot of things for you that are worthwhile to point out. The only prerequisite to this is that you need to go and configure the linting rules. You need to make them work for you. You shouldn't take someone else's preferences and run with them, because then you will go crazy and you feel boxed in. But if you actually put in the effort to get good linting rules, then they will pay off handsomely for you. So highly, highly recommended. In terms of the simple thing you can do to raise the quality of your entire code base, do install a linter. As you gradually turn on the rules, you also gradually go in and fix the errors that they are reporting. Very, very nice. And this is based on the assumption that we have a build toolchain background that is just something background of JavaScript and something in the browser directly. There's something in between that processes things for us. We now enter our own decade, which is not finished yet, which also already contains gems such as Korean music video of Gangnam Style. My studio sounds crazy about this, and I understand it. So now we have a build toolchain that is extremely valuable. It brings a big mind shift in that, hey, we can compile our JavaScript. We never thought about this before because it was a scripting language, okay? This completely solves the problem of having to write old JavaScript because someone might run it on their browser. Now you write new, nice JavaScript, have it compiled back to base level, lowest common denominator, works everywhere JavaScript, which you basically don't have to look at. But that just runs in the browser. So you have sort of a JavaScript compiler. Because people in the web front-end world are hipsters, they have invented a word for this called transpiler, which you will hear sometimes. Those of us who sort of know our history with compilers and so on, we know that a transpiler just means compiler, comma, and you can stop listening now because I don't know what I'm talking about. But that has been very, very valuable. CoffeeScript was one of the early languages that said, hey, let's refurbish JavaScript and write it the way we want it, like a nice combination of Python and Ruby, and then it just compiles down to JavaScript. Nowadays, the demand for CoffeeScript is less. It hasn't completely died out yet, but actually the rest of ordinary JavaScript and other nice languages have caught up, so they started invading this niche. And there's literally hundreds of languages that now compile to JavaScript that you can do this with. But I would say the most important one of them today is newer JavaScript, new school JavaScript that you write so that you can run the lowest common denominator code in your browser. And someone might say, hey, wait a minute. This sounds like a pipe dream because I know, with the sort of pessimist or realist that I am, that I will have to debug that generated code, and that's horrible. And actually, no. That problem was solved also along the way. There's something called source maps, which just sits along with when your code gets compiled and that generated code that you never have to look at lands in your browser. There's also source maps saying, hey, all this generated code, there are sort of arrows or pointers back to the code that you wrote, your original code. And so when debugging sessions turns up, either in your browser or in your IDE, they actually end up in your original authored code. As long as this mapping file works perfectly, and it tends to work really, really well actually, you're fine. You don't have to look at the generated code, so that's a really nice solution. Last person on the list, Carl Simpson. This is another author, and he's also on Twitter. And I would say it's fairly influential. You can see that by the fact that his GitHub project has many, many stars. I don't know what top 10 or something like that is. It's one of the most popular JavaScript projects out there, JavaScript-related projects out there, and it's not even called this book. Or it's a series of books. It's called You Don't Know JavaScript, which, yeah, it's a provocative title, for sure, but it actually has a bit of a story behind it as well. Carl was on an interview where he basically, in the interview itself, got rejected because it was felt that he didn't know JavaScript enough. And his first reaction was, what? Sure, I know JavaScript. That's ridiculous. That's very mean of you to say. And then he thought for a while, actually, and he thought, hey, I never actually studied this language in depth. I've never actually taken the time to sit down with JavaScript and really, really go through it and really, really understand it. And isn't that strange? I mean, a language that I use every day and that's sort of my bread and butter, I haven't looked at it, really. So, this Kickstarter-funded book series was his effort to do that for himself and for everyone else. And of course it's well worth it. And it's free online, or you can buy the books and then you pay for the dead fees. But do read it, really. It's longer than JavaScript, the good parts, and there's some photo out there which I didn't include, but where these books sort of stack up to the big thick book as well. So then you know approximately how much there's to read as well. But really, really nice. It goes through things like the compilation process, variable scopes, how do types work, how do grammars work, how do operators work, and so on. These promise things that we talk about, what's the advantage and disadvantage compared to just passing functions to functions. All that and much, much more in these books. I could not recommend them strongly enough. If you have one takeaway from this talk, is that you need to read these books because none of us knows JavaScript. Also, it's kind of a nice counterpoint to the stern prescriptivism of Crockford here, where Crockford says, only use these parts because these parts are the only things that are good. Kyle says, learn all the parts. Really, because whether it's in there because it was a mistake or it's in there because it's a great feature, it's part of your tool set when you have chosen JavaScript as a language, and you should be familiar with it. You can find it in someone else's code, or you can find, a safe, healthy way to use it, even though it's potentially a dangerous feature. So now sort of all doors open, and we get challenged to use JavaScript in nice and productive ways. He says this: I gently challenge you to journey down that bumpy road less traveled and to embrace all that JavaScript is and can do. That knowledge, no technique, no framework, no popular buzzword acronym of the week will be beyond your understanding. And doesn't that sound nice? So let's finish up by talking a little bit about the emerging present and the future with ECMAScript 6. So ECMAScript 6 is the last version that started rolling in and entering people's lives. And we at Ediment have been really happy to embrace the ECMAScript 6 features, for example. And nowadays we think about our courses as they should be about this, because anything older than that will just gradually go away. And we should prepare people for the environment that's now sort of spreading out. Again, that's especially true because of these compiler tool chains, where you get that today, no questions asked. The browsers can get all that they like, can still compile down to something that everyone can use. Of course, you have to prepare for that. You have to see what environment you're in and at least have a build switching. So we started phrasing the debate as old school JavaScript, which is ECMAScript 5 and lower, versus new school JavaScript, which is ECMAScript 6 and higher. And that has been very fruitful for us for thinking about this, how to present it and introduce it.